So all the instances is started. Please try to log in and let us know if you are anyone have facing any problem. Please start to maybe in chat box you can respond. Done like yesterday.
Once you start the instance, make sure you are in the FairSec environment.
Hello, sir.
Yes.
Um, how to change from bash to
Honda activate FairSec.
okay.
Okay, so only four groups are there. Rest of the groups. Okay. 2, 3, 4, 5, 6, 7. Group 2, 3, then 4, 7 is done. Okay, group 2 done. One, two, three. 3 is not there. Four done, five done, six done, seven done, eight done, nine done, 10. Okay, so three groups left, 3, 10, 12. So is there anybody who's coming for these groups or doing or something? Because I see less number of participants. Okay. Please log in and activate the FairSec environment so that we can get started. So group 10 and 12, is there anyone who is doing on those groups?
12 is not there. I think from 10 nobody is doing.
Okay.
Yesterday also I think it's no one.
So should we get started or should we wait?
Yeah, we can start. I think Kishore KS.
Actually, I'm having fever, so I can't take up the can
Okay.
just let's continue.
Okay, then from group 10, Vishnu is there. So Kishore. Yeah. Hello, Kishore.
Yeah. I'm able to
So
hear you.
is anybody in your group? Anybody else join except you? Anybody else join?
I'm not sure. Like Shantanu is there yesterday. I'm not sure
Yeah,
whether
so
he joined.
Shantanu was there, but
You
he
can
is
assign
not
to me.
able to do.
I will just try to. If no one is there, you can just assign to me.
Yeah,
I'll
you
try
can do. It's
Yeah.
already assigned.
Okay, fine. I will try to. I will start that. Okay, it's fine. Okay, you guys continue. I will
Yeah.
pick up.
Okay, fine. Yeah, Harbin, we can start.
Okay. Yesterday we downloaded the data for training. We also cleaned the data for training. Okay, and so there is a data folder here, and there is a data folder inside Vakyansh folder as well. If you go to Vakyansh folder, you'll see there is a data folder inside that as well. So to avoid confusion, what I'm going to do is I'm going to rename the data that we downloaded yesterday. Okay, so I would be moving data to IATM. Okay, so now my data folder has been renamed to IATM just to avoid confusion between the Vakyansh experimentation data folder and the original data that we have. Okay, so if you want, you can also do the same. So inside IATM, I have my two folders, raw and processed, like yesterday. So process contains the training data that we just cleaned yesterday. Raw contains the dev, eval, and train data. So we won't be cleaning the dev or eval set because whenever you are in some competition or something, whatever cleaning you do for the training set, you shouldn't do for the eval set or dev set uh, in speech competition, just because you don't know how your submission would be evaluated if you submit your entry in the competition. So hence, we want to keep the dev and eval set as it is. If you want to check, you can check. There are no cell or bn or any kind of tags in the dev or eval set already. Okay, so there are no tags present in the dev or eval set. So the data is, so the transcripts are already clean in the dev anywhere set that has been provided by IITM uh, Madras. Okay, so we only clean the train data. So that is why inside the process folder we only have a folder for the train data. Okay, so yesterday somebody asked me that what if we have a data in a single file? So I mean all the text data in a single file, right? So it turns out eventually all the text data, I mean, so this is the data how you should have raw data and process data, but the data that is passed to the model, because the model when it tries to read the file, the audio files and the text files, there has to be a particular formatting which the model has to read. So first we will prepare that format and then I will explain what that format is and how do you do it. Okay, so go to Vakyansh experimentation folder. So it is again mentioned in the steps for fine tuning, preparing data for fine tuning in the same MD file that we had yesterday, the timeline MD file. I'll just copy this link and now I'll go to scripts. So head over to Vakyansh experimentation scripts and fine tuning. Okay, as I said yesterday, most we will be doing most of our work inside this using the scripts that are present inside the scripts folder only. So since we are doing fine tuning, so we will head over to the scripts, and inside the scripts we'll head over to fine tuning. If you do ls here, you'll see two files. One is prepare data and one is start fine tuning. And I think for pre-training also you will have these two files, which is prepare data and start pre-training. Okay, so I'll come back to fine tuning again. So what essentially we are saying is that if you need to do fine tuning, there are just two steps for it. The first step is you prepare the data. So when I say prepare the data for the model, I mean how the model uses the data. Okay, so I just have to open prepare data.sh. So vi prepare data.sh. Okay, this command is not present here, but vi prepare data.sh. Now what I have to do is I have to provide my training path and my validation path. Okay, the training path of my data where my data is present and the validation path of my data where it is present. Okay, so if you do vi and you open prepare data.sh, press I, and inside the train wave path you have to give the path of where your data resides. So in my disk, my data resides in Harveen, IITM, and then we have processed. Okay. So this is the path for the train data in my machine. In your machine, it might be different. Please go ahead and check what is the full path of the training data. And my validation data is also, my validation data instead of processed, it is present in the raw, in the dev.
So Harvin, just I have one query. So that you are directly doing fine tuning. You are not doing. We are using some pre-trained model. The
Yes,
earlier
we will be
pre-trained
using,
model.
yes, we are using a pre-trained model, so we will be downloading that as well. But first
Okay.
we'll prepare the data
Prepare
for,
the data for fine tuning. Okay,
yeah.
thank you.
Okay. You go to this path, you do vi prepare data. And SI and update paths for plane wave path and valid wave path. Then there is the third parameter, which is make valid from train. So sometimes what happens is that we do not have a separate validation set. So we extract validation set out of training only. Since here we already have a validation set, we don't want to take the validation set from training. So instead of 1, I would do 0 here. And that's all. You just need to change 3 values.
Can you repeat, Erwin? I just missed.
Yes. So sometimes what happens is we do not have a separate validation set, right? So we extract validation set from the training set.
Okay.
So in those cases, this switch, this make valid from train would be 1. Okay, because you're extracting the validation set from the training itself. But here, since we have a separate validation set, we don't need to do that. Okay, so in case if it is 1, you can also specify the percentage of validation set that you want from the training set. Okay, so here it is 10%, you can have 25 accordingly if you provide the values.
0.1 means 10%, huh?
Yes, default is 10%, but you can keep on variable. I mean, you can keep on your variable. You can have 25%, 5%, anything you want.
Yeah. So have you guys checked that how much data is good for, suppose we want a good accuracy? So what is the percentage ratio for training and validation?
So it depends on how much training data you have. So if you have like 1,000 hours of data, then 10% of 1,000 will be 100 hours, which will be too much, right? So you do not want a 10% of 1,000 hours to be in validation set. So in that case, only 1% might be enough, right? So 10 hours might be enough. But in case you only have 10 hours, then 1 hour may not be enough. So you might need to have like 20%, like 2 hours of data for the validation set.
Okay. So suppose means how much hours of data we good for good accuracy? That means suppose minimum 10 hours data. Or
Yes. So as I talked yesterday, so we have fine-tuned models with even 10 hours of data. But what we recommend for Indic language, the minimum amount of label data should be in the range of 50 to 100 hours if you want to get a good model.
thank you.
So you just have to update 3 things, 3 variables. One is the train wave path, which contains the path for your training set. Then the valid wave path, which contains the path for your validation set. And that's it. And then you have to just update the make valid from train equal to 0. So once you have done is, what you have to do is bash prepare data.
Sir.
Yes.
Hello, sir.
Yes.
Sir, sorry, I'm not very much familiar with Vim. So,
Okay.
I while editing, I made some errors. So, Uh, can I just
Okay,
show
so
what
you
to do
can
because I am unable to understand?
okay,
Pardon,
yeah.
sir.
Please go ahead. Yeah. Yes, go ahead. Go ahead, please.
So I'll just share my screen once.
Okay.
Please go ahead.
Is it visible?
Uh,
So is my
Not right.
terminal visible?
No, no, no.
No, not right
Some
now.
internet issue.
Yes, now it is.
Yeah, it is visible now.
Is it fine now, sir?
Yes.
So what to do now?
So
It's not visible. I made the changes,
you
but
can
then yeah.
okay. So you can press Control Z and maybe get out of this terminal first. Control Z.
Yeah. But I made the changes, but
Okay.
there was a slight error in the file. So I wanted to
Yes.
rectify it.
Yes. So you have to go inside the
So
folder, right?
what should,
So you have to go inside Vakyansh
inside this
scripts
shell file.
and find it. Yes. I mean the folder Vakyansh experimentation. No, not VI CD. You have to go where at the path where the shell file is present. Right now you are outside. Do an ls. Do an ls. Yes. Here you have to go in this path. Then scripts, cd scripts, and then fine tuning. Now you open the file. Start fine tuning.
Okay, sir, I got it. Okay, thank you, sir. Okay,
Yeah.
thanks.
Okay.
Sir, after editing, we have to press WQ, colon WQ.
Yes, or
Escape
you
colon
can
W.
press Shift ZZ. How to rectify this error? Prepare data. So when are you getting this error? Uh,
Just after running that one, what is that? Bash prepare data.sh.
okay, can you share your screen once? We'll check the bash file whether there is any error.
Kim, you can present your
Just
screen.
wait a minute.
Yeah, it is.
So
I
you
think
can
you are now
click
you
on
are.
this button. So you will be able to present your screen.
Kim, are you able to present? Hello. Hello.
Sir, actually, I'm opening so many files, and when I click on the tab button, the one that I'm into the file, it's not showing, so I cannot share it here.
Mm,
Okay.
Yes, to save the file, either you can press Shift ZZ or you can
WQ.
write colon WQ.
Yeah. That I have done, but
So probably some other changes were also happened in your prepared data file, and yeah, most probably your if condition is not closed properly. So if there's no fi, so at the end of your if condition, so
So so even in some terminals, yes, you will be able to run directly the prepare data.sh, but for the external syntax sake, you can use bash prepare as of now. So I have not shown you what happens when you run this file. So probably I'll just show you once this gets fixed.
Harbin, is there any difference between dot slash and bash?
No, so I think if you have the permissions, then you can make that executable with dot forward slash, but you just run every bash script with bash format in the starting.
Okay, even that have not permission, I can run it using bash. Are you telling?
Yes,
Okay, okay.
yes.
yeah. So to run it with dot slash, you have to specify the compiler at the top of the first line.
Yeah, yeah.
So currently it is not specified in our file. So if that is not specified, you cannot make the file executable. So all our scripts will run with bash and not dot slash, at least as of now.
So once you run bash prepare data, you'll see some processing started happening. Okay, like this. So these are the number of files are getting read now. Okay, we had like close to 27,000 files, right? So this counter will go till 27,000. So it will show you writing training manifest file done with 27172 records. So this is for the training set, and I think there is a typo here. It should be writing validation manifest file done with 331 records. So this is the manifest has been written for the audio files now. Now the text files are getting processed. Okay, I will shortly explain the complete process, what happens. So word file is generated, lexicon file is generated, and you will see the dictionary file of length 62 has also been created. Okay, so it means that we have 62 unique characters in our data set. Okay, and there is no punctuation marks present. We also do a check for that, and then we also show you the statistics for your training set, like total duration on args is 40, min duration of a file is 0.29 second, max duration of a file is 15 seconds, mean duration is 5.33 seconds, and the number of files less than or equal to 1 second, how many number of files are there, and total duration of files less than equal to 1 second is 0.04 hours. And similarly, you can see the duration for validation set as well. I mean the statistics. So total duration is 4.9, min duration is 0.6, max duration is 15, and so on. So once you have done this, please let me know. So, Sushmita, there is some problem with your paths, okay? Because if you're not able to find anything, if your script is not able to find anything, then there is a problem with your path.
Okay,
Please
sir.
check your path, the train well path.
Okay, sir.
Hello, sir. Like I am getting an error. Like minimum argument is an empty
Yeah.
sequence. This error I'm getting.
Uh, please show. Can you
Yeah,
share
yes,
your
I will
screen?
share.
So there is some problem with your validation path. Your training path is right, but there is some problem with
Okay,
your
I will.
validation path.
Okay.
Can you check? You can press E. Yes.
Okay, sorry. Yeah, correct.
It should be M, right?
Yeah.
Yeah.
Sorry.
Insert type.
Yes. Okay.
Now you can try to run.
Yeah. Okay. Thank you.
So Sajal, you can check your training and validation paths. There might be some problem with the path that you're providing.
Yes, sir.
Yeah, please you can share, Sajal.
Is it visible?
Yes, we can see your screen here. So there is a
Slash missing.
forward slash in front of home in validation path.
Oh, here now.
Yes.
I press I. Sajal.
That to space 5. Yeah. That's okay.
Yes.
Now escape.
You press escape. You either press shift and ZZ or right. This is also fine. Yes.
So then this type of error will come. No?
No. You press bash. You can execute the command again. Bash prepare. Yeah. Okay. Now
Okay.
no. Okay. So. I resume sharing. So, what was the purpose of running this command? The purpose of running this command was to prepare the data in a form in which wave-to-wake algorithm can pick the data. Okay. So, there is a data folder inside Vakyansh wave-to-wake experimentation. Okay. So, I'll go to that folder, data, and then fine tuning. because we are running the script for fine tuning, so the data would also be present inside the fine tuning folder. If you go inside the fine tuning folder and do ls, you check certain number of files would be created for you. Okay, so dict.ltr.text, then you have lexicon, you have train.ltr, train.tsv, valid.ltr, valid.tsv. I mean, we'll discuss what all these files do, but essentially inside the fine tuning folder, you will have all these files present. Okay, so first we'll check what is present in train.tsv. Okay, we'll check what is present in train.tsv. So you'll find in train.tsv, the first line is the path of your training path. I mean the path that you have provided in the bash file. And in the second line, you would see this is the file number, and there is a number associated here. Okay, I'll quickly come to this point, like what is this number? But you would see something like a training path at the as a first line, and the name of the wave file, and these are the frames inside the wave file. Okay, so frames in the sense like how much duration the audio file is. So if
It's 25 millisecond frames, are you telling, Arvind?
no, so this is like our file is as sample at 16,000, right? So 18,721 divided by 16,000. So this file would be of duration 1.1 second.
So that is the number of samples in that file.
Yes, number of samples. Okay, so you'll find that it is present for all the wave files with the corresponding frames that are present. Okay, so if you divide this by 16,000, you'll get the duration of the. Yes.
Actually, like in the IATM database, like they have mentioned segments also, right? But we are considering total audio file. Then how will it map, sir? I mean, the
No.
text .txt file, they have just given us some small segments, right?
Yes.
How we are going to map here? We are just taking total, total sequence, total audio sequence, and then calculating this frame level information.
No. I'll tell you the mapping. Okay, so this is just the TSP file. So there are other files as well, like train.ltr and train.word.
Okay.
So these files are interrelated to each other.
Okay.
So for every data set, so this is the file. The TSP file is the file where you have information on your audio files only. Okay, so you have information on your audio files. What is the information? The information is the name of the wave file, and the relative path is present on the top. And then the second argument is a number of frames. So first, just focus on this file, which contains the wave path. Now, coming to your question, how we will know, like in this audio file, this text is present. Okay, so there is another file which is called train.wrd. Okay, so if you head that, you'll see the text is present here. Okay, so this text has a direct mapping to this file. Okay, as the name of the wave file and the text file is same, so this file corresponds to this file right here. So if you go and check LNW wave, it would contain this text. Okay, similarly for Kolkata, this file, wave file, you would have the text like this. Okay, so the train and the word mapping is present in two different files. Okay, in TSP files, you have information about your audio files, and in your WRD files you have information about your text, that this is my audio file and this is my text file.
Okay, sir. Yeah.
Okay.
Yeah.
Apart from TSV and WRD, there is another file which is LTR file. Let's check what is there in LTR. So essentially what is there in LTR is you have the same text that you had in the WRD file, but now your each and every character is separated by a space. Okay, so and your every word, after your every word there is a word separator, so this is known as word separator. Okay, so this is the symbol for OR. So this is useful for wave to wave to when it actually does frame level mapping, the 25 millisecond frames, and it has to predict the character in every frame. So this file is useful for wave to wave at that point of time when it actually maps like how good its prediction was. Okay, so there are three files. One is
how it helps. Arvind, can
so
you
in every 25 millisecond there is a prediction on the character, right? But this is WRD file, right? This won't help. So
Correct.
this is the file which helps there because it tells that whether the prediction at that 25 millisecond was correct or not.
So that bar symbol, whatever you are giving, that is a separator. So that
is a
also
word
you are
separator.
word separator. That is also including that 64 in between the 64 characters.
Yes, yes, that is also included in the dict. If you go, I'll just show you the dict, and you'll
It
see
is
that.
showing no that bar equal to 0.
Yes, yes, yes. That is the first character always in dict. Whenever you create your dict, the bar will always come at the top with a 0 frequency. The significance of bar is that it tells wave to wave like where is the word separation. Okay, where how the two words are separated from each other inside the LTR file.
Okay, so that 0 is what? It is frequency or frequency
No,
of occurrence in the
0.
training set, or
No. 0 is something that we have hard coded. So every time it will be 0 only for you. Okay, and every time the bar will be at the top of the dict file because that is a requirement. Because bar is a mandatory character in any dictionary. Okay, so bar has to be present in every dictionary. So that is why it is present in the as the first line in the dictionary for any dictionary you create.
Excuse me, Harvin.
Yeah.
Is this program is specifically written for Hindi language, or it can be run on the other languages also?
No, it is generic program. It is written for any language in the world.
Okay, so these are automatically generated files.
Yes, these are automatically generated files based on what the script that you have run previously, right? Prepare data script. So once you execute that script, these files will be generated for you. Earlier, this folder would have been empty for you, this folder. After executing this script, these files have been generated for you.
Okay, so manually, what are the files we need to generate? One is, I think, lexicon and transcript.
I'll come to lexicon. So for any type of data set, right? So for like you had a train data set, you will get three files. One is train.tsv, one is train.ltr, and one is train.word. And similarly for valid set also you would have three files. One is LTR, one is word, one is TSV. So in TSV you would have the audio information. In word you would have the text, and in LTR you would have the space and bar separated text. Same like this.
So that dicted file will be created from the training set only, not
dict file will be created from the training set, and lexicon file will also be created from the training set. Okay, so if you want
possibility that some symbols may have present in the testing set and may not present in the training set.
Yes,
And in
there is a
that case,
possibility.
how
Yes,
will you
there is a
handle that?
possibility.
Okay,
But
okay, that maybe, yeah, correct.
yes, there is a possibility, but we want to focus just on the training set, because in
Correct, correct.
testing anything can come, right? That is not an issue. But we need to create the dict and lexicon only just from the training set. Okay, so if you want to check, what you can do is delete all these files and run the script again, and these files will be generated again for you. Okay, if you just want to check whether these are auto-generated files or not. But the point here is, for every data set that is present, you will get three files. One is TSV, one is LTR, and one is Word. We come to dict and lexicon files. What are they? By the time you might even guess what is a dict file. So dict file is created from your training set. So this is the set of characters that is present inside your training set only. Okay. Yesterday we did some cleaning because some of the characters were not present in the Hindi language. Once we did that cleaning, we were sure that the transcripts are now the ones that are there in Hindi. And the dict also validates the same. There is no foreign character inside the dict from any other language, and only Hindi characters are shown inside this dict. Okay, so this is the character, and this is the number of times it has appeared in the training set. Okay, the frequency doesn't matter, but we wanted for the user to have analysis of the training set. So hence we have shown the frequency, but as such for wave to wake, the frequency of any word or something doesn't matters. But just for your analysis sake, we have provided the frequency of that particular character inside your training set.
But at the time of testing, maybe if the training number of frequency have less, maybe that hampers, no, during the testing.
No, because see, as I told yesterday as well, if you have a good training set that is representative of the population, then even in the testing set you would have a similar distribution of symbols.
Correct.
And
yeah, every language have that kind of distribution. Okay.
Yes. Yeah. But if you are in an extreme case where only particular words are spoken and there is no coverage of the entire vocabulary, then there can be a problem with the testing set if the testing set has a different distribution than the training set
of these characters. Yeah.
Yeah,
Yes.
Harvin.
Yeah.
So like you have told that in the second column, you're finding that how many times it appears, no, in this running files, training data sets.
Yes.
So basically you are applying some phoneme recognizer or something else?
No, we already have the text, right? So this file is created from the text file.
Okay,
so we are just counting the frequency of characters.
Okay.
So this dict file is created from the text file.
Okay.
It's not created from the audio file.
Hello, sir.
Yeah.
Suppose we are working in a language. In that language, there is no script, written script. So can I use this model using English script?
In that language, what is there? Sorry, I missed the question.
Suppose there are lots of language in India. Those don't have any written script.
Okay.
That means if you want to write the language, you have to write in English or Hindi or anything. So in that case, can this algorithm will be helpful using English script?
Yes. See, for any language, suppose there are some languages which don't have their own script, okay, but are written either in Roman or Devanagari or something, right? So the way, like, I'm not sure that there is a language like Bodo which doesn't have its own script. Okay, so it's written either in Roman or Devanagari. Okay, so your training text has to be in the same way, like you want the output to be. Okay.
Okay.
If you want, so first of all, you have to ask yourself, how would you write if you have to write on a paper? In which script you would write? Then you have to find data in that particular script. Okay.
Yes.
And once you find it training data, then you just have to use these commands and these files will be generated for you. Okay. So
Harvin,
yes.
Sisir here. I have one confusion in the sense like in Kaldi we have a very structured way of doing, no? Like we have utterance ID, then corresponding is text file or transcription, then part. All those things are there. For Web2Vec actually, the file systems, like whatever this Word file is there, then this. LST file is there, then your TSB file is there. They are actually that we need to put in sequence, no? Like if one transcription will miss in some place, then it will like whole sequence will be mismatched, right?
Yes. So the scripts that we have run, I mean, the scripts at the backend that have run, uh, I mean, takes care of this. Okay, so no transcript or it will be mixed or it will be missed. Even if any transcript is empty, it would be shown as an empty line in the Word file.
Yes.
Okay, so
yeah,
you
yes,
don't.
yes.
Yes.
That I got it. But what I'm telling is that like if like by mistake I'm telling, like by mistake if I miss something in that word train.word file,
Right.
then it will happen. That actually that's maybe FAIRSQ maybe like upgrade something like that in Kaldi, whatever they have utterance IDs and corresponding transcriptions. That way actually it's
Yes, the scope of mistake is there. So that is
yes.
why we created this framework, so that you just have to provide the paths and we will take care of the rest.
Great. Yes.
But if you go and create manually, of course, you can make some mistake.
Yes.
If you make some mistake, then your labels would not be the actual labels. Okay, so it's
Actual
just
labels,
noise, right? So you're creating noise. So that is why we have created a framework in which
Yes.
scope of mistake is very, very less.
Great, yes, exactly. That's great, actually. Yes.
Okay.
Thanks.
One thing I observed, train.ltr, LTR has decomposes a character into what is specific to Hindi language. So it means there is a dependency on the language.
No, it decomposes based on the language character set. So I can show you an example. It is not dependent on Hindi. You can try it on English, or you can try it on Punjabi or any other language, because what it essentially does is like how a word is created. Okay, and to just know that how a particular word is created, you just need to do a list of the word. Okay, so
Yeah.
I can show you.
So that is fine. My question is, for a new language, we need to indicate that this belongs to.
No. You do list on any language, the result would be the decomposition of letters.
So the script will automatically detect the language and decompose, right?
Yeah,
No, there is no language detection. Actually, these are generic methods that work independent of the language. I'll show
maybe
you
due
one.
to that Unicode, no? That each
I'll show you one example.
Okay, you okay.
Unicode mapping, no?
Okay.
Yeah. I'll show you one example. Okay.
They got it. Yeah.
Okay.
Because of Unicode mapping, it can be done. Okay.
Yes, because see, the system knows what a word is being made of different characters, right? Like what are the different characters to get those? And we have already normalized our training set before coming to this step. Okay, so it knows the decomposition thing, how the decomposition is happening in the text file. So all that information is stored in the text file, and there's nothing getting stored inside our framework or any framework. You can basically do a list of any word from any language, and you will get a list of different characters in that word. Okay. So I can just, so if you do Python and you do list of, let's say, it knows that how this word has been created using these different characters. Okay. And now I trial something in Punjabi. And I'll try again. You see, the Punjabi characters are also separated. Okay, so this is something that has to be the understanding of Python for languages, right? So the Python understands that this word is a combination of these characters, right? So even
Yeah,
if you do,
yeah, got it. I think Dibbandhu clearly mentioned it is based on the Unicode. So as long as the language is getting supported in Unicode, so
yes, yes, yes,
yeah.
absolutely.
If language is not getting supported, then it's
yes. So I think Python has Unicode support. I think Unicode support is present for every language, but Python also supports for all languages.
Yeah.
So apart from that, there is another file called lexicon.lst. Let's check what is there in lexicon.lst file. Now you will see that in this file, on the left side, there are unique words inside your training set. I mean, on the left side, you will have the unique words that are present inside your training set. And on the right side, you will have a decomposed form of those words, like we had in the word file. Okay. So this is very important in the time when we are trying to have code blocks inside the quantization module. So, I mean, it's kind of an advanced concept. I'm not going into it, but the point here is that if inside the training, it has seen some word, the algorithm has seen some word previously, then that word should be present in the code block. And from the code, so code block is essentially a dictionary. Okay, so from that dictionary, the same word can be picked and the same decomposition can be done. Okay, but here you just have to understand that on the left side it is a word, and on the right side it is a decomposition of the word, and these are unique words in your training set. And this also gives you the coverage. I mean, how many unique words do you have in your training set? The more unique words you have in your training set, the better is the chance for your model to be a generalized model. Okay, so suppose if you are building a command recognition system in which only 8 or 9 commands would be spoken at a time, then in your lexicon file you would only have those 8 or 9 commands. Okay, so that is not a generalized system. You cannot you cannot expect that system to work better on any sentence that you speak. It can only get better at those commands. Okay, so if you check the length of the lexicon file, so there are like close to 12,000 words, unique words, close to 13,000 unique words that are present in our training set. Of course, these are less, but by any means, these are not too much less. These are okay for us to have a good generalized model.
Sir?
Yeah.
What if the script is from right to left? Say something like Urdu.
Okay. Yes. So see, we are yet to experiment on that thing. Okay, so we want to create an Urdu ASR. So maybe in 2-3 weeks we'll get that answer. We have not actually got that answer yet, but once we do that, we might get an answer, like whether this script works from right to left as well.
Okay, sir.
Yeah. But just for final revision, I would say that once you have provided the train and the validation set, there will be three files created for each set. So one is a train.tsv, which contains the audio files. Another is train.word, which contains the text uh, from your transcripts. And then there is a train.ltr, which contains space separated decomposition of the text, space and bar separated. And similarly for the validation set. And from the training set, your dict.ltr.txt would be created, and your lexicon.lst would be created. In lexicon, you would have unique words in your training set and the corresponding decomposition for those unique words. Okay, so by this, I think we are now done. We are finally done. I mean, we are finally now ready to start our fine tuning process. Okay, so I mean, from the data side, there are some more preparations that we need to do apart from data. But from the data side, now my preparation is done for the fine tuning step. Okay. So, Salam, are you still facing this issue? It might be some path related issue. So if you're still facing, I would recommend please check your path and so that we can proceed further. Yeah,
Yes,
please.
Salam, you can share your screen else.
Yes, hello, Salam.
Yes, I think he's sharing. Yeah, your screen is visible. Yeah.
Sir.
Please
Yeah,
open your file.
I'm getting error in this part.
Yes, yes, please open your file, this prepare data.sh.
Sir, how to open, sir?
VI, prepare.sh. VI.
Oh,
Yes. So, um,
here one mistake.
so Sajal, please make sure you're not doing head of dict. You should do cat of dict to see the entire dict. So head only displays by default the top 10 entries.
Okay. Thank you, sir.
Yeah. So all these scripts are running in parallel, so they are using all your CPU power. Because if this would have been done on a single CPU, then it would have taken like at least 20-30 minutes to run the full scripts. Okay, but all the scripts are running in parallel. You can check also how the increment happens when it is shown on the screen. Okay, so this is also done. So maybe you can stop sharing. If you want, you can go ahead and check the data folder, the fine tuning folder inside the data folder to check if all those 8 files have been created. And whatever I'm saying, whatever we are discussing, I hope, yeah, screen is visible. So everything you'll find documented. So everything you'll find documented inside the repository itself. Okay, if you want to tomorrow, if you want to do something on your own, so these are the things that you might come handy for you at that point of time. Okay, so it's not that only I would speak in this session and there is nothing documented. So everything is documented here. Okay. Coming now to the point where we are now ready with the data. Now the only step left, okay, let me go to timeline and I'll open fine tuning from scratch MD. Okay, now to do fine tuning, you need a pre-trained model. Okay, because you would do essentially a fine tuning is what? It's a finer fully connected layer on the top of a pre-trained network, right? So you need a pre-trained network to get started with fine tuning. Okay, so you need to get a fine-tuned model. If you go to our model repository, you check, we have open sourced some of the pre-trained models, like the one which is trained only on Hindi, the one which is trained on Kannada, and one is CLS RIL, which is trained on 10,000 hours of training data. Okay, and there is a research paper also published for the same. In case you want to see, you can go ahead and check this paper to find more details. But now is the time where we go and we get the pre-trained model. Okay, so I'll come back to my original repository. So this is my wave 2 experimentation repository. So remember where we used to save checkpoints. Yesterday we talked about that all the checkpoints would be saved within the checkpoint directory. Okay, so I'll go to checkpoint. I'll do a ls. Since we are bringing a pre-trained model, okay, so since we are bringing a pre-trained model, we have to go inside the pre-training folder. Okay? We have to go inside the pre-training folder and we have to get this model. So how to get this model? This is the command wget, and this is the path of the model. I'll paste these commands in the chat window. So that you can also do with me. Okay, now you do an ls, you'll see that we have the pre-trained model CLS RIL 23.pt inside checkpoints pre-training. Please make sure that this model is present inside pre-training folder because it's a pre-trained model. It's not a fine-tuned model. Okay, so please be sure of that. Once you're done, please let me know so that we can just proceed with the last and final step. 11 is done. Okay. Okay, Jeevan. If you want to check the size, you can go ahead and check the size as well. ls minus lth command. This would be around 1.1 GB of size. Okay, no issues, you're fine. If anybody is still downloading, please let me know. Apart from group 5.
Sir, are we going to do the even the pre-train from scratch?
No, we won't be doing pre-training because pre-training is an expensive step in terms of GPUs. You need at least 32 to 64 GPUs to start pre-training. Okay. So it's a very expensive step. So that is why we have already pre-trained a model and open source for the community, because even we used NVIDIA A100s on the cloud to pre-train that model, because that takes a lot of GPU memory and all, and as such researchers do not have access to that much compute. If you have access to that much compute, you can very well run the pre-training using the same steps. Inside the prepare data, you can prepare data, and then after you can start pre-training from the bash script.
So,
Yeah.
yes. So the minimum amount is 32 GPUs. Is it so?
Yes. Yes, the minimum amount is 32 GPUs. Even in the fine tuning, the minimum amount is 24 GPUs. But there is an option to simulate 24 GPUs from your single GPU in fine tuning. But in pre-training, that simulation doesn't works very well. Okay. So in pre-training, it is said that if you have what do you say, 32 actual GPUs, then only your training would start and it would get completed. Because see, it's a very slow process as well. Fine tuning is relatively very fast process, but pre-training takes like 3 to 4 weeks, even on 32 GPUs or 16 GPUs. Okay. So the model that we have open sourced, it took us around 2 to 3 weeks to train on cloud on 16 GPUs.
16 GPUs.
Yes.
Of what size? Like
it was 800 GPU, so one GPU was of 40 GB.
40 GB.
Yes.
40.
Oh,
okay.
So Tesla A100 you have used?
Yes. Yes. So I can show you.
Pre-training it takes 60 GPUs, is it?
Yes. So you can check the WAN DB logs also present
Yes.
in the website. and I can show you what were the configuration of. So you can see that it took us quite a while to reduce the loss and all. We'll discuss all these parameters. So in the overview tab, in the overview tab, total compute 3 days. Just a second. Where do I get it? So you can check this GPU type A100, 40 GB of GPU, and GPU count was 16. So that's the top level machine that is available on cloud. So nothing is available after this.
Okay, okay.
Okay.
And ideally, we would have wanted 32
CPU
GPU.
count is also 96, correct?
Yes,
96.
CPU count is also 96. It's a very high compute
High computing.
process. Okay, so
Yes,
that is why
yes.
we won't be doing pre-training in this step. We are saying
It
that.
is telling that state is crashed.
Sorry.
The state crashed. Why it is telling?
State crash. Yeah, I mean, we stop training by killing the process, right?
Okay.
Because there is no state of completion for the training, right? So we usually stop the instance when we are done with the training, or we kill the process using
Okay,
sudo.
by saying that training accuracy and this training loss and validation loss, you killed that.
Yes, yes, yes. We actually decide that now it is done, so let's switch off the instance. So,
Sir, is there any possibility that, like, if we have 16 GPUs with some each GPU is around 12 GB, can we parallelly shift the data on the CPU if the CPU power is more, count is more?
yes, but see, you have to fiddle around a lot of the hardware, right? Hardware in the sense like how PyTorch manages the hardware and the memory, right? So, but right now, if you have 16 GPUs, you can still run the pre-training. I've shown you that we ran the pre-training on 16 GPUs itself, but we had a large amount of CPU count as well because in
Yeah.
CPUs, uh, we have multiple workers. Okay,
Yes,
so
yes,
there is a concept of workers in PyTorch, right? Data
yes,
loaders.
yes, sir.
So whenever one batch is in the memory, the next 36 batches are already present in the memory
Yeah.
for processing. Okay, and this is made possible by the fact that we are using high compute GPU parts, and when one batch is getting processed on a GPU, the other 36 batches are getting read and processed inside the CPU. And then the only conversion is from bringing those 36 batches one by one to GPU.
Okay.
Okay, so I have a question. So what is the RAM requirement? I think you have taken all 10,000 data at a time to the loaded to the RAM, correct? Then only you can go for that, no? That
So
fallen data loading.
since it's a data loader,
Yeah.
all 10,000 hours of data is not loaded at once inside the RAM.
Okay.
Okay. So it is loaded in a batch fashion. So if you said like I want to load only 32 batches, 32 samples at once in a batch, so only those 32 samples would be loaded. But since your number of workers are six, so 6 into 32 batches will start getting prepared in the CPU RAM memory. Okay, so that process is being controlled by the number of workers parameter inside the config which we have. I'll show you the config as well, in which we define the number of parameters. But the main
What is the ideal size of batch size?
what is the ideal size of
Batch.
Ideal batch size, I think it
ideal
is.
batch size? Okay, so again, it is dependent on your GPU size. If you have a 40 GB GPU, you can fit in a lot of batches. But if you have a 16 GB GPU, you have to fit in a small amount of batches. We'll talk about the batch size.
Assuming we have a sufficient like compute.
Yeah, we will talk about where you can give the batch size, because here we do not give batch size as batch size, but we give batch size as a function of tokens. like how many tokens can a GPU handle at a particular time. So remember in the training file, we had in the train.tsv file, we had a file name and then we had frames written in front of the file name, right? So
Yes.
those frames had a significance in training because those frames will let the computer decide that whether a combination of certain files can fit inside a particular batch or not, because you can limit the batch size with the total number of frames. Okay, so we'll come to the configuration part, like what is the configuration part, how I can configure what amount of batches are getting picked and how quickly they are getting picked. Okay, we'll come to that part. First, I want to get you started with the fine tuning, because if we do not start now, then by the end of the day, we might not have a model to infer on. Okay, so once that fine tuning gets started, we can talk about all these factors that we are talking right now. Okay,
Okay.
so okay, so now we have the pre-trained model, which is CLS RIL 23.pt. And now we have the data, we have the pre-trained model. The next step is we want to decide on a configuration that we want to use for our fine tuning. Okay, as I discussed yesterday, config folder will be present inside config fine tuning. And if you do an ls, you would see that there are two configurations that are present. One is a base 100H YAML and one is base 10H YAML. The contents of this configuration we'll discuss in detail one by one. What does each and everything means? But because I just want you to get started, let's decide on a configuration. So for this fine tuning, we will be using base 10H config. So let me just open it and show you. So this is the base NH configuration, where a number of things are present which we have not talked about, but we will talk about in certain point of time. I mean, just maybe after half an hour, 15 minutes. Okay, but the point here is that we have decided that we will use base 10H as a configuration to do my fine tuning. That's it. Okay, so now my data is ready inside the data folder. My checkpoints, the pre-trained checkpoint is ready inside the checkpoint folder. My config is already present inside the config folder. The next step I just want to do is I just want to go inside scripts, inside fine tuning, and there is a file called we start fine tuning. Okay, and if you check the contents of this file, you will see that there are three values that you can change. One is the config name. So config name remains as it is, because we have decided that we will be using base 10 H config. The number of GPUs you have. Okay. So this is currently we are running on a single machine. So what you can do is do one here. Okay. And then the third step here is run in NoHub. What happens is when you start a process, a Python process, if your connection to the terminal gets lost, then you have to restart that Python process again. Okay. So what you can do is you can run your Python process in the backend. Okay, so you can run your Python process in the backend. So even if your connection to the terminal gets lost, that process will keep on running on the instance. Okay, so you have to make sure the instance is always running, right? So if you want a program to also run when the instance is running, and if the program is independent of your internet connection, then you have to run the program in the background. So if you want to run your Python process in the background, switch it to 1. If you want to run as it is, switch it to 0. We'll come to a point where we want to run to 1 or 0. But these are the only three things that is advisable for you to change inside this configuration, inside this bash file. Okay, so first is the config name. Second is the number of GPUs that you have, which can be 3, 4. People who have their own machines, they can have 3 or 4 GPUs here. But people who are on cloud, please edit it to 1, and we'll just save this one. So just do this process. I'm giving you the command, and then we'll take a short break, and after a short break we'll start with the will zero run it on GPU. No, you need a GPU to run this, unfortunately, because this on CPU it will take like endless time to run it, but you have to provide at least one GPU to get started with. Okay, so you go to this folder, you open this file, and you set GPU's parameter to 1. For people on the cloud, for people who have their own hardware, please mention the number of GPUs that you want to use. It can be 3, it can be 2, it can be 4, depending upon what GPUs are available when you do the NVIDIA SMI command. Great. So, now we are in a position where we can just go ahead and start fine tuning. Nothing else needs to get changed. Okay, so we don't need to change anything because our data is ready, our pre-trained model is ready. We know the config that we want to use. Now we can start with the fine tuning. Yeah. Hello. Is there a question?
No, maybe you can start.
Okay. So please, update the GPUs, and then maybe we can get started. So I think we can take a 10 minutes short break here. So once we are back from the break, we'll start the fine tuning, and we'll check how the different metrics are reducing and how this is happening, and what is the configuration, what is the token size, what is the batch size, all of this we'll check, but we'll start the fine tuning first. Okay, so we can take a, I think, 10 minutes break, Jagbandhu.
Yeah, 10 minutes break we can take.
Yeah, okay, sure.
So we will, this is 11:50 we will meet.
Okay, sure.
Surikan sir, are you telling something?
Yeah, no problem, no problem. 11:50 will meet, sir. Yes.
Hello, Arvind sir.
Yes.
Yeah, sir. Actually, in the config there is a find folder, right? In that we have base underscore 10h dot YAML file, right? YAML file. In that the data set in the configuration, maximum token says some 320000, right?
Yes.
So I mean